Hi everyone, let's go over problem 1. First, let's examine the flower class. Here we have two flowers, and one is rose, and then one is daisy. So for part 1, it says, select the output displayed by the interactive Python interpreter when a code is evaluated, and it may have multiple lines. So what happens here? So we first call rose.describe, which prints the rose is blue and has 30 petals. The describe method doesn't really return anything explicitly, and so it returns none. And then we store this none in the variable description, and then we print this description, which outputs none. So the output would be the first line, which is the rose is blue and has 30 petals. Line 2 is none. For part 2, we have daisy.addVisit, small b, and rose.addVisit, small b. And then we want to see what the results would be for daisy.bVisits is rose.bVisits. And here we're actually adding small b to daisy.bVisits, and then we add small b to b.visits. And then we check if daisy.bVisits and rose.bvisits refer to the same object in memory. Each flower instance has its own separate list for b_visits, so they're distinct objects even though if they are the same values. The is operator checks for object identity, not value equality, so the result would be false. We have a lot of add visit calls in part C, and just a reminder what add visit does, it adds to the b_visits if it does not exist already within the list. So we have rose.addVisit, which gives rose a lucky bee, and then we have daisy addVisit, and it gives it a small b, and then we call rose.addVisit cute bee, and then daisy.addVisit happy bee, and then we call rose.addVisit lucky bee, and we don't add anything this time because we already have a lucky bee. Let's go look at the first statement. We want to check if these two lists are equivalent, and they're not because they have different bees. So this is false, so then we don't check it. And then the next statement checks if the length is 2 for daisy, and it is for 2, so we check that. And the next checks for flower.bVisits, and since the flower class doesn't have an overall attribute, that's b_visits, this is not for. And then we check if the length of daisy.bVisits is the same as the length of rose.bVisits, and it is the same because they're both 2. And finally, we have rose.bVisits is equal to lucky bee, cute bee, and this is the case. But it's not case for the following because the order actually matters. Part D asks us to explain what the purpose of addVisit method in the flower class does. Like how we did in problem below, when we look back at it, it appends the b name if it's not already in b.visits. So we can just say that the method tracks which b has visited, and it also does not track duplicates. E and F are kind of unrelated to the problems before. So for part E, let's break this down. So the first here, we want to see this would evaluate to 0 because integer division rounds down, and 100 mod 2 evaluates to 0 because there's no remainders, and so then leaving with 0 and negative 45, and this would evaluate to 0. So then x would be just 0. And then for y, the list 1, 2, 3 dot append 4 would evaluate to none because this modifies the list, but it actually returns none. And then since none is false, the OR operator evaluates the right side, the list pop, and the pop returns the last element, which is 3. So now we have it a true value, so it's going to return to 3. So it's going to be the first choice, 0, 3. For F, we want to trace through each of the statements again. So shall is 1, 2, 3, and hello is delish. And then shall 2 is 2, and then which then gets printed. And then shall is reassigned to shall 0, 0, which then is again 1, and we probably won't use this again, and so it doesn't matter. And then we define the nested function bonjour, and then we call bonjour yum, which would print hola, and returns hello, which is delish. And then hola returns the result of bonjour yum, which is delish. So then the output would be this. And we see this, that's in this answer. G, the code is the same as part F, but now we're evaluating high. As we have this determined already in part F, high gets assigned to the value delish. So then when we evaluate high in the interactive interpreter, it displays the value delish.